We got section 3-4 today, derivatives of exponential and logarithmic functions. We have e to the x graphed here, and the y values of e to the x are very low over here, but the derivative is also very shallow. And then as the values of y increase, so do the slopes. So the slopes are getting more and more positive, and the value of e to the x is getting more and more positive. So it turns out that the derivative of e to the x is e to the x, interestingly enough. So in example 1, we really like taking the derivative of e to the x. Using the formula, find derivative of this, so dy dx is equal to e to the x plus x squared. It's the same thing, except you always have to worry about the chain rule. So then times 1 plus 2x. Now that doesn't have anything to do with e to the x, it just happens to be the inside function. So that's the derivative of that one. The derivative of an exponential, that's what this says. The derivative of the derivative of 2 to the x, so a to the u, is equal to, so the derivative, let's do this. The derivative of this is 2 to the x times the natural log of 2. And I'm sure they have the development of it in the section, or if you want to see it developed, Google it. But that's the derivative of an exponential. At what point on the graph of the function does a tangent line have slope 21? So dy dx, the slope is equal to 2 to the t times the natural log of 2. And then the derivative of minus 3 is 0. We want to know when that is equal to 21. So let's divide by natural log of 2. So 21 divided by natural log of 2. And we'll represent that with 3 decimal places, even though I'm going to use the value in the calculator. So that 30.296 is only a representation of the number. So let's take the natural log of both sides. And we can bring down the t. So we'll do, did I take the natural log of both sides? I didn't. Natural log, natural log. So natural log of this value divided by natural log of 2. So t is equal to 4.921. But more to the point is this right here. That's the derivative of 2 to the t. Everything else is just what they can ask you along with taking the derivative. Derivative of natural log of x. Now that we know the derivative of e to the x, it is relatively easy to find the derivative of its inverse function, the natural log of x. So they write y equals natural log of x, but then take it to exponential right away. For example, if you had log base 2 of 8 is equal to 3, that's just a true statement. And 2 to the third is equal to 8. So the top one is the log equation, the bottom one is the exponential. Logs always equal the exponent, so this is always the exponent right there. Well, then we take the derivative of both sides. Derivative of e to the y is e to the y, but then times that's implicit, times the chain rule. And the derivative of x is 1. So the derivative is 1 over e to the y because they divide by e, but e to the y is x. So the derivative of natural log of x is equal to the reciprocal of what we're taking the natural log of. Derivative of natural log of x is equal to 1 over x. And 1 over x is reciprocal. Example 3, a tangent through the origin. A line with slope m passes through the origin and is tangent to the graph of y equals natural log of x. What is the value of m? So here's the natural log of x. There's the graph. And we got this vertical asymptote right here. They say that a line passes through the origin, 0, 0, and is tangent somewhere to the graph. And we don't know what that point is, and they want to know the slope of the tangent line. So if we knew the x value, we'd have the point x, natural log of x. To find the y, we'd take the natural log of the x and we'd find the y value. I like this problem because its old slope is equal to new slope. So old slope is natural log of x minus 0 over x minus 0. It is y2 minus y1 over x2 minus x1. That's old slope between two points. The new slope is the derivative of natural log of x, which is 1 over x. It's reciprocal. This is natural log of x over x is equal to 1 over x. Well, if we have 3/5 is equal to x over 5, what does x have to be? Must be 3, right? Has to be 3. If the denominators are the same, then we don't have to worry about, if the denominator is the same, we don't have to worry about the denominators. We can kind of throw those out for now. And we just need natural log of x equal to 1. Now, as long as that's the same, then those two fractions will be equal to each other. So x equals e to the first. So x is e. But it doesn't ask for x. It asks for what is the value of m. What's the slope? Well, that's probably the simplest version of the slope right there. So m is equal to 1 over e. Derivative of log base a of x. To find the derivative of log base a of x for an arbitrary base, we use the change of base formula for logarithms to express log base a of x in terms of natural logs. Now, what are they talking about? If you had log base 2 of 8 is equal to 3, let's say. 2 to the third is 8. You could take the natural log of both sides. Bring the 3 down, and that 3 is the same as natural log of 8 over natural log of 2. So we went from log base 2 to log base e. Now right here, I could have taken the log base of anything, and it's going to work. So you can see that natural log of 8 divided by natural log of 2 is 3. So they're saying that log base a of x is the same as natural log of x over natural log of a. That's called change of base. But natural log of a, that's a constant. So the derivative of this is, well, 1 over natural log of a. That's just a constant. It follows along. And then the derivative of natural log of x is 1 over x. So the derivative is sitting right here. Now let's look at something a little more useful. The derivative of log base, let's say 2 of x, would be 1 over x natural log of 2. I think that makes it a little more clear as to what's going on. When you put an a in there, it looks like a variable, but it's not. It's a constant. Then down here it just says make sure you include the chain rule in it. Right there. Make sure you include the derivative of the inside. Going the long way with the chain rule. Well, what's log base a of a to the sine of x? Like what's log base 6 of 6 squared? Guess what that evaluates to? 2, right? Log base 6 has base 6, and 6 squared has base 6. They undo each other. They're inverse operations. So what's log base a of a to the sine? Sine. And what's the derivative of sine? Cosine. So the answer to this better be cosine. All right, but we're going to do this the really long way. That's why I say going the long way. So dy dx is equal to, the derivative of the log is 1 over a to the sine of x times the natural log of a. So there's the derivative of the log. Then on the inside of that, you have an exponential. The derivative of exponential is a to the sine of x times the natural log of a. And then finally, the derivative of sine is cosine. There we go. I don't recommend doing it that way, but you could, and you get the same answer. You get the derivative of sine. Finding a domain. If f of x is natural log of x minus 3, find f prime. State the domain of f prime, excuse me. So here's the natural log of x. And it has a vertical asymptote right there. Then we can move this vertical asymptote 3 to the right. That's the transformation. 1, 2, 3 to the right. Here's the new vertical asymptote. And here's the actual equation that we're looking at right there. Well, the graph does not exist to the left of 3. As a matter of fact, it doesn't even exist at 3. So the domain is x must be greater than 3. There's the domain of f. Now let's take the derivative. F prime of x is 1 over x minus 3. The derivative of natural log is reciprocal, essentially, 1 over this thing. Well, now, if this wasn't a derivative, let's say that was just a function, the domain is anything except 3. Negative 5 is good, 1 over negative 8. Negative 10 is good, 1 over negative 13. That's fine. That's a good answer. But it's not just a function. It came from a function. It came from a function that has a restricted domain. X must be greater than 3, so x has to be greater than 3 here as well, even though the function itself has way more of a domain. But you can't have a slope of a tangent line where you don't have a function. You can't have a derivative where the function doesn't exist. So that's why we have to just restrict the domain of the derivative, even though the function itself would have very little restrictions, just one number. Did I explain that okay? Make sense? Can't have a derivative where it doesn't exist. All right. Find the derivative of each. These are two different things. This is an exponential function. This is not an exponential function. So y prime on this is pi x to the pi minus 1. We use the power rule there. But x is not a power. X could be any power under the sun. It's the variable. So the derivative on this one, this is an exponential function. So pi to the x times the natural log of pi. It's a very subtle difference, but it's a very big difference. It's a completely different function. It's not even in the same family. Completely different, even though it looks very much the same. Make sure you know the difference between these two. Now, they use a symbol to throw you off. I could use another symbol, e to the x versus y equals x to the e. Y prime here is just e to the x times the natural log of e. Well, what's the natural log of e? 1. So that's why we don't write natural log of e. It's 1 times 1. Y prime here is ex to the e minus 1. That's not an exponential. Now we use the power rule. Even though it's kind of a crazy number. It's 2.718. All right, now we got to grind it out. There's e to the x. We'll practice a couple exponentials. We'll practice a few natural logs and a few logs, and then there's another natural log at the end. So there's our 4 different derivatives that we've learned. We're going to practice it. We're going to grind it out. How many times you run over bags this year? A lot. Feel like you're good on the bags? Guess what they're going to make you do? Do more, yeah. Because you got to practice. You got to work on your footwork. You got to work on getting your knees up, right? We got to grind it out. We got to practice it. That's why you got to do this homework. And we spend 1 day on this section. This is it. We'll review it tomorrow. We'll review it Monday, but this is it. You have to do your homework. You got to grind it out. You got to practice this. All right, here we go. Let's run over some bags here. Y prime is equal to 2e to the 2x. The derivative is e to the 2x, but then times the derivative of the inside, which is 2. Y prime here is negative 5e to the negative 5x. This one is negative 1/4 e to the negative x over 4. There we go. Those, we love e. They go quick. They're the same thing, except you have to worry about the chain rule. 8's a little harder. First times the derivative of second plus second times the derivative of the first. So we got product rule there. And then first times the derivative of second plus the second times the derivative of the first. The derivative of the first would be negative 1, so I left it as a negative, even though the product rule has a plus. Well, you know, we go answer hunting here. We're going to take an e to the x out. X squared plus 2x minus x minus 1. And then e to the x, x squared plus x minus 1. And then later we'll set it equal to 0, find some zeros, factor more if we have to. But for right now, we're good. We're just finding the derivative. And then 10 is e to the x squared. We like e because you write the same thing, and then you just have to worry about the chain rule. So then times 2x. So that's e to the x. 12 starts exponentials. So y prime is 9 to the negative x times the natural log of 9. There's the exponential part, but the inside is negative x, and the derivative of that is negative 1. So negative. (14) y prime is 3 to the cotangent of x times the natural log of 3. So that's the derivative of the exponential part. You write the same thing and then times the natural log of base. We actually do the same thing with e to the x, but natural log of e is 1. So that's a waste of time. So there's really only 3 things that we do, quite frankly. This is actually just a version of the exponential. We just don't write the extra little piece. 16. Squared is the outside. So y prime is 2 natural log of x. There's multiply by 2. Oh, yeah, go ahead. Oh, I forgot the cotangent part. Times negative cosecant squared of x. There we go. I got caught up in talking about that other stuff. Thank you. I appreciate it. No, yeah, don't let me get away with that. Multiply the power rule, reduce power by 1, and then times 1 over x. So maybe we just write it like that. The derivative natural log is 1 over x. It's reciprocal. 18. Y prime is reciprocal of this. I could write 1 over 10 over x, but that's x over 10. And then times, let's see, that's 10x to the negative 1. So times negative 10x to the negative 2. So these cancel out. You get negative x over x squared. So negative 1 over x. Derivative of the inside. The chain rule follows you all the time. No matter how many derivatives we find, the chain rule is always there, which makes antiderivative lots and lots of fun. But that's later. Speaking of antiderivative, I actually recognize this as the antiderivative of natural log of x. Let's do the derivative. First times the derivative of second plus second times the derivative of the first, and then minus 1. So we have 1 plus natural log of x minus 1, so C, natural log of x. The derivative of that is natural log of x, so the antiderivative of natural log of x is actually that. We won't get to that for a while yet. I think it's chapter 5, if I remember right. How about logs? 22, y prime is equal to 1 over the square root of x times the natural log of 5. So it's 1 over this thing, and then the natural log of the base. And it's all in the denominator. Then times 1/2 x to the negative 1/2. So we have 1 over 2 squared of x, natural log of 5. That's 1 over 2x, natural log of 5. (24) is a little tricky. Shame on them. It's y equals log base 2 of x to the negative 1. So remember, if the top is a constant, don't use the quotient rule. Bring that denominator up, make it a negative power. It ends up being easier in my opinion. So y prime is equal to negative log base 2 of x to the negative 2 times 1 over x natural log of 2. So there's the derivative of the log piece. So we clean this up a little bit. Negative 1 over x natural log of 2, log base 2 of x to the negative, not to the negative now, excuse me. Come on, there we go. Log base 2x squared, there we go. I'm really running out of room. 26. Y prime is 1 over 1 plus x natural log of 3 times the natural log of 3 but then the derivative of the inside, this is really 1 plus, it's like 1 plus 4x, because natural log of 3 is a number. So the derivative of this would just be 4. So the derivative of this would just be natural log of 3. So times natural log of 3, those cancel out, and we got the answer. Natural log of 3 just happens to be a decimal value rather than some nice value. All right, last one. I know, you wanted much more, but this is the last one. I get it. Y prime is 1 over 10 to the x. So derivative natural log is reciprocal, and then times the derivative of 10 to the x, which is 10 to the x natural log of 10, which is natural log of 10. Which is kind of interesting that it becomes a constant. But natural log is a log, and 10 to the x is an exponential. So they don't quite cancel each other out. They're not quite inverses. They're different bases. But they kind of cancel each other out in a way because the derivative ends up just being a constant. There's no variable in there anymore. Which is kind of interesting. All right, any questions on any of these? That's the heart of what we're doing right there. And then we can ask you other questions like set it equal to 5 and solve. Very similar to the one we did in the example. A line with slope m passes through the origin and is tangent to that. What is the value of m? What's the slope? So natural log of x over 3 kind of squeezes this a little bit, but the shape is still pretty much the same thing. So a line goes through the origin and it's tangent to this graph, like that. Something like that. So we have x natural log of x over 3 as a point, and we have 0, 0 as a point. So I like to describe this as old equals new. So old would be natural log of x over 3 minus 0 over x minus 0, and the new is 3 over x times 1/3. So it's reciprocal of x over 3, and then the derivative of x over 3 is 1/3. So these cancel out. So you have natural log of x over 3 over x is equal to 1 over x. Well, now the denominators are the same. We just got to make the numerators the same. So natural log of x over 3 is equal to 1. X over 3 is equal to e. x is 3e. But it didn't ask for x, it asked for m. So we'll plug that back in here. M is equal to 1 over 3e. Find a function with the given derivative. So on 44, y must be 5 natural log of x plus c. Because that's how we can get x down into the denominator, is by taking the derivative of natural log of x. It's reciprocal. 46, f. Oh, I like this one. There we go. We love e to the x. It's very easy. And 48, this one's a little harder. If we say that y is equal to 2 to the x, the derivative of 2 to the x is 2 to the x times the natural log of 2. You see, that doesn't have the natural log of 2. Somehow that went away. But natural log of 2 is a constant, and constants just follow along. So if I wrote that, the derivative would be this. The natural log of 2 in the denominator would just tag along, and it would end up being canceled. So that one's a little bit of a wrinkle to it. And there we have antiderivative. That's kind of where we're headed. We got some blank space down at the bottom. So let's kind of organize our information here. The derivative of e to the x. Here's this is so you don't have to look back into those notes as much. Is e to the x. Then I think we did exponential. I'll give a specific example. I won't use a. 2 to the x is 2 to the x, natural log of 2. So if there's a 3 there or a 4 there or a 5 there, it's the same thing. That's why they put an a there. Oh, do you see that? You guys didn't see it. There's a truck going by with probably 30 feet of plastic hanging out of the back of it. No kidding, it was long. Derivative of natural log of x. I think we did this next. That's reciprocal. And finally, the derivative of, I'll give a specific example. How about log base 2 of x is 1 over x natural log of 2. Now, what I don't include on any of those is the chain rule. You got to remember the chain rule all the time. Those are the 4 you need to know, but really these 2 are exactly the same thing. We just don't write natural log of e here, because natural log of e is 1. So those are exactly the same. So technically, there's probably only 3 derivatives you need to know. We just throw that e to the x in there because it's really easy, really easy.